Yeah. Here's what I'll probably do throughout the year. There will be days where it's more convenient for us, certainly faster, for me to distribute a little code to you. I don't use Canvas very much, but Canvas is certainly convenient for this. So if you'd hop over to Canvas, please, the Canvas for the class,
Canvas.
and you'll find that there's an announcement there. You should see a page that looks very much like this. You see one that says 8/23 code examples. This is just so you don't have to like type things in really fast. And then if you follow the link where it says here, you should find yourself at a page that looks like this. Are you with me? Thumbs up. Okay. And then, okay, so what you can now do is this. At this point, all you could do is like run the code and look at the code.
Announcement.
But what you need to do, what you will do, I'm sure, is hit that fork button at the top right. And then what that will do is it will create a copy of the project and put that in your list of REPLs, okay? Which means that you can now go and edit the code. So if you hit fork, and it actually will work for me in exactly the way that it will work for you, because this is on my second Google account, and the project itself resides in the first Google account. So from the point of view of this REPL, I'm not the owner of the account. So, are you here? Did it not come up?
It doesn't show it as a link on mine.
It doesn't?
His link won't work either.
Really?
Go to your email. If you have an application.
It was, you gotta click on the words at the top and then it goes brings it to the right page.
Oh, okay.
Did you click on the,
Are we all there? No. Yeah, are you at Canvas?
Yeah, try it, but it's not.
The announcement for the class?
There.
Why is it not a live link? Did you have the issue that it wasn't a live link on the announcement?
The actual
You
announcement.
have to click on the words.
Yeah. You have to click on what words?
Yeah, you have
Right
to open the
above-
actual
the
announcement.
title, right above all
Yeah.
sections.
Oh, wait.
Right above the 823 code example?
Oh, yeah.
Oh, then you actually get there. I didn't know that's how kind of works. It seems like sort of an extra step for nothing.
click on,
Oh, well, okay, so you should find yourself at this code. Now, again, my intent here is to review some of what we've done to make sure that you're clear about what functions are. And I will do that, or the term that I will use to do that is the term abstraction, okay, because that's ultimately what function creation is about. It's about a process called abstraction. And given the way that I had you work in chapter one, that is, you had to write multiple programs that were highly similar, that did the same kinds of computation, like convert Fahrenheit to Celsius for multiple values of Fahrenheit. Given the way that I set it up like that, it's just sort of very natural to discuss functions in this way. Okay, so here's what I've done. Okay, so I've written a little bit of code for you here up at the top. What I want to look at, first of all, is lines 1 through 9. This is the kind of work that we did back in chapter 1. Okay, so I define the value of pi, okay, and you might wonder what's the significance of the uppercase here? Why did I use uppercase here and not elsewhere? Ultimately, it doesn't matter. Python doesn't care, but programmers will typically use all uppercase for a value that's like constant. That is a value that will never change at any point in the program, and pi is like that, right? I mean, it's a constant. Pi won't be different tomorrow. So that's an approximation of pi that we will use, 3.14159. And then lines 3 through 6, I compute the radius of a circle of, not the radius, but the area of a circle of radius 6, and then I print that to the screen. And then lines 7 through 9, I do it again for a circle of radius 12. Okay, and of course, you noticed this back in chapter 1, and it's obvious. Lines 3 through 5 and then lines 7 through 9 are highly similar to one another. Okay, in fact, they're almost identical to one another. And I tell you what, let's actually write the code so that it won't crash. Probably should have done this, but we will write a function in just a moment. It begins on line 13 called circ area, but there was nothing in the body of that function. And then I tell you what, I just don't want this to crash. So how about you go down to line number 30 and put the hashtag in front of it so it's no longer a line of code. Do you remember what the hashtag does? It's comment, right? That's exactly right. So that means that Python ignores it. That's for a human reader to read. So, oh, we still crash. So I guess I knew this. You can't have just comments as the body of a function, so I actually put pass in there. So yeah, so we were now able to run the program and it did not crash. So let's talk about what happens when you write a function, okay? And we're about to do that. Well, I have two sentences, each 2 words for you to describe what's about to happen. And it's this, it's up on the board as well. It's parameterize differences, functionalize similarities. And hopefully by the time I'm done with this discussion, you will understand exactly what that means. Okay, so I'll say it again. And I will keep these bits of Python wisdom up on the board because they're really, really important conceptually. To think like Python, you need to understand all of these. So again, it's parameterize differences, functionalize similarities. Okay, so let's talk about what that means. When you look at lines, the first code chunk, first of all, 3 through 5, and then the second code chunk, 7 through 9, what's the difference? Yes. The radius. Different values are assigned. Okay, so even though these 2 code chunks are highly similar, there is a difference. Now, the bit of Python wisdom is parameterize differences. So, parameterize radius. What does that mean? Make it a parameter. You remember what a parameter is? The parameter is, well, you can think about it just syntactically, that is, what you have to type out. It's what has to go inside of parentheses. What does that mean? Okay, tell you what, I'll drop a word on you. Semantically. So the semantics is what it means. The syntax is like the symbols that you have to put together, okay, to write Python or whatever language. Okay, so what does it mean now that we have a parameter called radius? That will be the input value to the function. Remember that functions always have inputs, then they do some kind of computation, and then they produce an output. The inputs come through the parameters, okay? And of course, the outputs come out through the return statement, okay? So that's what has to go in, which should make perfect sense, right? Because, what do I need to compute the area of a circle? I need a value for the radius. That's the parameter, okay? So we parameterize differences. That one difference, the value of radius, it became a parameter. Okay, so the second sentence, this bit of Python wisdom, is functionalize similarities. Okay, and what is like the crucial similarity here? The crucial similarity occurs on the computation line 4 and then identically on line number 8. So what I'll do is I will simply Control C that, and then I will paste that in over the tabs. Okay, so the computation that the function will do is identical to the computation that was done by each of those code chunks. Okay, so the similarities became the body of the function. Okay, differences become the parameter, the similarity become the body of the function. And then, of course, what do I need to do to make this a complete function? I have to return it, right? So I have to return the value of area circ. Okay, and then you can see how this works. Okay, let's actually run this now. Remember that. Did I type something in wrong? Yeah.
Circ area, not area circ.
Circ area is the name of the function.
Oh.
Area circ is, sorry, that's kind of my fault because I didn't choose variables very carefully. They're too close to one another, but it is area circ. So let's run. Remember that the Python doesn't just like automatically know what you've done in the code editor until you hit the run button. Okay, and then just to make sure how it is that functions get used, and that circ area function has not been used yet. Well, how do you use it? And again, the official name of this, the name I'll usually use is call. How does one call the function? Well, one types the name of the function, and then one gives values. One gives values for the parameters. Okay, so the parameter here is radius. So let's send a value of 6. And that's good because we know what the area should be, right? So we can compare that to what it should be. And it's the same as what we had before. And then we can call it again, right? So I'll call it again with the value of 12. which is, yeah, the same as it was before. So, make sure that you understand just sort of the mechanics of this, how this worked. When I did circ area, 6 in parentheses, and then hit enter, that 6 was sent to the function where it became the value of the parameter radius. Okay, Python did that. It's a bit like it created a line like number 3, sort of for itself, right? But just as surely as line number 3 gave the value of 6 to radius, when I hit enter after circ area 6, 6 became the value of the parameter radius. And then just like on line number 4, now on line number 14, we did the computation to get the area of the circle. And then, of course, to complete the function, we have to actually return that value. Okay. This is what functions do. Okay. This is what functions do. It's abstraction. Okay. This process wherein we parameterize the differences and functionalize the similarities. We brought what was multiple lines, multiple chunks of code into a single chunk. Okay. And that's what abstraction does. All right, so the second topic that I'd like to talk about is composition, because this is something that you will absolutely want to do, okay? And I'm going to go back to 31 and line 31 and remove the pass, and I'll remove the hashtag in front of the C because I'm about to write a line of code. Okay, so I'll pick back up on what I talked about at the start of class about how you find the hypotenuse of a right triangle. You need the leg lengths A and B, right? You square both. You add those squares, and then you take the square root of that sum. Okay, take the square root of that sum. Now, what I've done is I've created a few helper functions. Now, I know they're incredibly simple, and they're sort of silly. They're so very simple, and you could have done without them, but I wish to make a point, and it's probably better to make the point with simple examples. And the point is this, is that very often you'll have some problem that you're supposed to solve, okay, and you'll write a function to solve that. That's what we do in this class. We write functions. But you'll realize that some part of what you have to do to solve that problem, you have already done with some previous function, okay? You've already done with some previous function. So instead of recreate the code of that previous function, what you can do is you can call that function inside the new function and use that old function's output value as part of the work that you have to do inside of this new function, okay? You don't have to go and recreate the code. Instead, you can use it. And that's what I'm about to do. Just to give you an example here, I'm about to write this function called find hypotenuse that will take leg lengths A and B and will return the hypotenuse length. See, and notice the comment here. This is something that I will emphasize more later on. It's often good to comment your functions. And typically when you comment a function, and again, that's what the hashtag does, it creates comments. Typically, the way that you comment a function is you say both what comes into the function and what goes out of the function. So what comes in as the values of the parameters, of course, often called arguments, that's what I call them in unit tests, are the lengths of the legs A and B, and what comes out, of course, by means of the return statement is the hypotenuse. Okay, so it's often good to comment functions like that. It's very welcome when somebody writes a function and then you read their comment that says what has to come in and what goes out, and you now understand. Okay. All right, so let's compute the value of C. And the way we will compute the value of C is we will make use of the functions that we already created. Well, again, what do you have to do? Well, the first thing you have to do is you have to square the A and the B. Okay, so we've got a square function, right? So I'm going to square the A and square the B. And I know this is not syntactically correct yet, but we'll build up to it, okay? So what's the square function do? It takes some value n, some number, and returns the square of it. And do notice that there is computation after the return. That is, Python has to do a little bit of work to figure out what value to return, but Python doesn't care. It'll just take the input value n and square it, and then whatever the result is, it will return that. Okay. You could definitely create another line of code that's a new variable, and you assign n squared to it, and then return that variable, but this works fine as well. Okay, so we need to square A and B. And then what do we need to do? Well, we need to sum too, right? Because we need to add the squares of the sums. So here's what I'm going to do. I'm going to call the sum2 function. And this is how you call a function, right? Function name followed by open parentheses. And the inputs, the two inputs that are needed, will be the outputs of square A and square B. So what Python will do when it sees this, and we're not quite done yet, but perhaps we should pause. What Python will do when it sees this is it goes, okay, sum2 function. I need two objects then that I'm supposed to sum. And then it looks inside of parentheses to find those objects. And inside parentheses, it finds square A and square B. So it goes, oh, okay, I got it. To find the objects that I'm supposed to sum, I need to go first and square A and square B. Okay, so it goes and it squares A and it squares B. And whatever is returned by those two function calls, that will be summed. Okay, that will be summed. What is the value of a function call? It's Python wisdom number 2 up on the board. The value of a function call is the value returned. Okay, so what Python do is it will evaluate square A. And what's the value of that? The value returned, which is A squared. Then it will evaluate square B. What's the value of that? Value returned, which is B squared. And then it will send A squared and B squared to sum 2. And the value of that is the sum of them. Okay, so what we have now is A squared plus B squared. And then what we have to do is we have to take the square root of that. Well, we've got a square root function. So SQRT. And then what I'm going to do is whatever that sum2 function returns, which will be the sum of the squares of A and B, that will then be sent to the square root function. Okay, that'll be sent to the square root function, and then the value returned, that will become the value of C. That is the square root of A squared plus B squared, and then we can return the value of C. Okay, this is the kind of thing that you will do in this chapter and also in other chapters as well. Okay, you will use functions already present in the construction of new functions. So let's actually run this and try to convince ourselves that it is correct. Okay, so find hypotenuse. And I will call that with 5 and 12 because I know what the answer is supposed to be. This is the idea of a test, of a function test. One knows what the output should be for certain inputs. So you put those inputs in and then compare the output to what you know it should be. And if your function gets that value, that's some confirmation that your function is correct. It's not conclusive verification that your function is correct because sometimes incorrect functions will produce correct values. Actually, sometimes functions that are in the end incorrect produce mostly correct values, but only occasionally produce incorrect values. Those can be really nasty cases, but we should get 13. So there it is. So it works. Okay, so it works. So those are the two topics. Okay, the two topics of abstraction, first of all, which is just really a review of what functions do. Okay, how they're written, what they mean for us, and then finally function composition as well. And then